Alright guys, so hopefully we got our random tools up and running. So the 6-sided die, the Monopoly dice, the 20-sided die, the cards from the deck, and the coin flip. Now what I want you to do is I kind of want you guys to test to see if this is actually truly reasonably random. And for an example, with the coin flip, if I were to flip a coin 1,000,000 times, how many times should I reasonably expect, not exactly, but within reason, how many times should I expect the coin to land on heads? It should be half the time, so 500,000 times. So what we're going to do is we're going to do that kind of idea. We're going to do this experiment kind of to see if our code is actually random. So first thing, obviously we need the import random. What I'm going to do is I'm going to take the 10-sided die and I'm going to do an experiment on it. 7 was my lucky piece, so let's quickly write that, just as a quick review. All right, so dice rolling equals true, while dice rolling equals true. I am going to x equals input, press enter to roll die. D for dice equals random dot randint 1 comma 10. I want to print D, and then if D equals 7, I'm going to print lucky, right? So that's the basic code that I had before, and every time I press enter, I'm going to roll the dice, and eventually I should get 7 and I get lucky. Cool. So my code kind of works. Now, what I want to do with this is really kind of take a step back and think, like, all right, I have this die. I can have the code run repetitively for basically forever. And if I do that, all I have to do really is remove this guy, right? And then it just keeps running, and you're seeing a bunch of luckies pop up. Now, I would want to ask myself, all right, if I were to do this like 1,000 times or 1,000,000 times or 1,000,000,000,000 times or however many times, how often should I get a 7, like the lucky, as the roll? Since there's 10 different options and 7 is one of the choices out of 10, it's a 10% chance. So if I roll this 1,000,000 times, I should get about 100,000 times where I get the value of D being 7, because it's a 1 out of 10 chance. Now, will that be perfect? No, it's random. It's like flipping a coin 10 times. You're not guaranteed 5 heads and 5 tails. That's just the most likely scenario to happen. All right, so what we're going to do is we're going to make this code run. We're going to have to change a couple things and eliminate a couple things and also add a couple pieces of logical code into it. And that's what we're going to test. When I finish this, you're going to choose 2 of the items that you've done with your tools from 9.1, and you are going to piece it together and do tests to make sure that your code, or Python in itself, or really your computer, I guess I could say, is actually behaving randomly. Because if you didn't, could you imagine making a slot machine and you calculate all the payouts and you calculate all the systems so that the casino earns its profits, and then all of a sudden that slot machine starts paying out more money than it takes in? That would be the most popular slot machine in the casino, and the casino will be losing money on that particular machine. So what we want to do is we're going to test it. We're going to run kind of like a simulation, and I'm going to have this happen 1,000,000 times. All right. So import random. That's obviously something that we need to keep. All right. So while dice rolling equals true, after how many times rolling the dice is this program going to stop? It's not. There's nothing that stops it, because dice underscore rolling is always going to have the value true and nothing changes it. But if I want this to happen 1,000,000 times, maybe I don't need the while loop. And I especially don't need dice rolling equals true. What I'm going to do is I'm going to make this code happen or repeat 1,000,000 times. Do you remember how to do that? I'll give you a second. Okay. So if you don't remember, we're going to use ranged loops. Remember, for I in range, and then the number of times that I want it to happen, 1, 0, 0, 0, 0, 0, 0. And for I in range, 1,000,000. So this program is going to happen 1,000,000 times. Let's try running it, see how it works. Oh, I've already noticed the problem. I do not want to sit here and press enter 1 million times to make this happen. So I think we need to get rid of this guy, because that was put in originally to slow down the code, so we had to press enter. So we don't need it anymore. Let's try running this now and see what we get. All right, that's running relatively quick, but I think we might be here for a while if it's happening 1 million times. In fact, I know it's running for 1 million times because my first version, the first time I taught this assignment to my students, I actually had them stay after school, signed into the computers, and then we ran this program overnight on the computer so that we would hopefully come back in the morning and have all of our results done. All right, so that's, I mean, it's kind of okay, but like, again, like, there's only like a couple hundred times happening. We're not even in, like, you look at the lines down here, we're not even in like 10,000 territory yet, and we got to do that 100 times over. I don't want to sit here for 100 times the length of what we just sat through and have it go through. So what I'm going to do, I mean, I'll let it run. It's not going to finish by the time we're finished on here. But what I'm going to do is I'm going to eliminate these print statements. And the reason why is these print statements aren't doing anything, really. They're just displaying. They're actually slowing down Python because it has to communicate to the monitor of the computer, hey, you need to display this text. And that's causing little bits of lags and delays when, if you add them all up over 1 million times spinning, you're going to be here all day. But what we also need to do is we also want to keep track of how many times we rolled a 7. All right, so what I'm going to do, up in the top outside of this loop, I'm going to say lucky count equals 0. So this is a counter, kind of like the score in that multiple choice quiz, that we started at 0, and then every time we get the value of 7, right, I'm going to say lucky count equals lucky count plus 1. The alternative way that some of you may be doing will be lucky count plus equals 1, which increases its own value by a single point. But I did want to leave the basic version of just incrementing a variable for you guys to look at. All right, so now if I were to run this, it's running, it's thinking, it's doing a lot of work right now, actually. All right, and then it's done. And what we can do is we can actually see inside of here. All right, let's give this just a second to kind of chill out for a minute. All right, so you can see all the programs running. If I were to run this again, you can see that the computer CPU usage is starting to spike with Python. All right, so I did it. That did all the 1 million procedures. By removing the print statements, I was able to very, very easily like bump up and increase the output speed of my code. All right, so let me just clean this up just so we can see like the most pure version of this. All right, but we still didn't get our results. So what I'm going to do is down at the bottom, and remember this is not going to be inside for the for I in range loop. I'm going to print lucky count. All right. Look, notice it is all the way to the back. It's not inside this loop, because if it is inside of the range loop, it's going to slow down our code way too much. So now I run it, and let's see what we get. All right, running, 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 boom, done. 100,056. Well, if we did this 1 million times, and out of 1 million times I got 100,056, remember we were expecting 100,000. I would say if these results came up, I would be completely convinced that we are good in terms of figuring out like all this stuff. 1,094. Like, again, we're so close to 100,000, I'd say that looks pretty darn good to me. These numbers are incredibly convincing that this code is quite, well put together. There we go, 99,875. Again, that's still so darn close to 10%. We're going to have variations because remember, in a random system, it doesn't guarantee that you're going to get exactly 10%, but it does hint that you'll probably get reasonably close to it. Now, if I were to run this code, and for some reason I were to get 600,000 out of 1 million, that's 60% of the time, that would make me be a little suspicious because you got to get the right number out of 1 through 10. And if all of a sudden I'm getting 60% of the time we're hitting that 1 in 10 chance, something's wrong there. So, I just kind of wanted to like point that out in terms of like your numbers will be different like within variation. But yeah, So anyway, your assignment for this is you're going to recreate this concept. You're going to be having any of your tools. You're going to choose a winning outcome. So for example, for a deck of cards, you could say I'm going to choose a random card, a 9 of diamonds, and I'm going to run my code 1,000,000 times where it randomly chooses a card from the deck. All right, so that could be shuffling it, right, and then flipping the top card. It could be whatever you want it to do in terms of like that, all right? It could be that. You could do something with a 6-sided die. You could say, you know what, I want to test to see if it happens, 1 out of 6 times. Well, if we need that, we can just open up our calculator, right? And we can figure out the estimated percentage, because it's one possible outcome out of 6. And that tells us it should be, so that's 0.16. If we figure that out into a percentage, roughly 16 to 17% of the time, we should get that specific chosen number. All right. Maybe you want to do something with a 20-sided die. That'll happen 1 out of 20 times, or 5%. Or if you want to be really adventurous, you could do a code where you figure out how many times, like out of 1,000,000 dice roll simulations, you get doubles. Or you could do something even crazier and say, like, hey, you know what? Like, rolling 2 dice, what are the odds of me rolling the total of value being 7? And 7, actually, with dice is a very interesting number because 7 is the most likely number to show up when you roll the dice. As you get older in your life, you may figure out that there are casino games. One of them is called craps, where you roll the dice, and them showing up as a 7 is actually a very significant number within that game, and it's most likely to happen. I think it's like between 30 and 45%. I forget what the exact number is, but it's really fascinating that like 7 is the most likely number to be rolled, and maybe that's why we look at 7 as such a lucky number as well. But anyway, pick any 2 of the choices of your code. You're going to want to save it somewhere different because you're going to be stripping and removing pieces of code from your programs. And yeah, so if you have any questions, be sure to post them, be sure to reach out to me, contact me, ask me in person. I don't care how you get my attention. But yeah, let me know if you need any assistance with getting this stuff up and running. Best of luck. We have one last thing to do where you're going to be kind of doing like a kind of big project where you're going to be building 2 or possibly all 3 of them if you're feeling really adventurous, using this new import random. Because as of right now, we built some simple little codes. Sure, we're going to test it to make sure it's random. That kind of helps build our math sense and our math how comfortable we are with the math. There we go. And then we're going to move on to making a kind of involved game. And then after that, we are moving right into that slot machine. All right. So with that in mind, get your code up and running. Make sure you get numbers that are pretty reasonable out of 1,000,000 times that you should have that happen. And yeah, best of luck, enjoy, and have some fun with this. All right, later.